2009 BC, problem number 3. We have this diver leaping from the edge of a diving platform into the pool below. And the figure shows the initial position of the diver and her position at a later time. At t seconds after she leaps, the horizontal distance from the front edge of the platform to the diver's shoulders, so we're basically using the diver's shoulders as the one point that we're going to pay attention to in this case. So the horizontal distance from the edge of the platform to the diver's shoulders is given by x of t, and the vertical distance from the water surface to her shoulders is given by y of t, where x and t and y of t are measured in meters. Now suppose that the diver's shoulders are 11.4 meters above the water when she makes her leap, and that dx dt equals 0.8 and dy dt equals 3.6 minus 9.8 t for t greater than or equal to 0, less than or equal to a, where a is the time that the diver's shoulders enter the water. So her shoulders start off 11.4 meters above the water, and a is the time at which she enters the water, her shoulders enter the water, and dx dt and dy dt are the rates of change of her horizontal and her vertical, or the horizontal and vertical position of her shoulders. So we're working with a parametrics problem here. And part A asks us to find the maximum vertical distance from the water surface to the diver's shoulders. So basically we're looking for the maximum value of y, and the maximum value of y will occur when dy dt is 0. And so that's pretty straightforward. We're just going to take dy dt, set it equal to 0, and solve for t. So we have 3.6 minus 9.8 t is equal to 0. 3.6 is equal to 9.8 t. And t is equal to 3.6 divided by 9.8. And since this is a calculator question, we can go ahead and use the calculator. We have 0.367. But I'm still going to go ahead and save that, all the digits of that, into alpha A. So I'm going to hit store into alpha A, and the value is there when I need it. Now it is important to note here that the question doesn't ask the time that the diver reaches their maximum vertical distance, but the actual maximum vertical distance. So we're going to have to find the y function and plug in that time. In order to find the y function, we're going to have to integrate. So we have the integral of 3.6 minus 9.8 t dt. Now one thing that we can do here, we do know that the diver starts at 11.4 meters. The shoulders are 11.4 meters above the water when she makes the leap. And at time t equals 0.367, she reaches her highest point. So what we could do is do a definite integral, which we can use our calculator for here. And that would start at time t equals 0 and go to time t equals a, where of course a is 0.367. And if we were to do that, all we would need to do then is to add that quantity, that change, onto 11.4, and it would give us the highest point. So if we were to add 11.4 plus the integral from 0 to a of 3.6 minus 9.8 t dt, we would get the highest point. And so I enter 3.6 minus 9.8x into y1. I zoom standard, and I'm going to find the integral from 0 to a, and that quantity is 0.661. I can use store to store that quantity in b. Now I add 11.4 plus b, and my answer is 12.061. And that is in meters. That is the maximum height that the diver attains. We'll carry on with b in the next video.